Most people that follow my channel know that I have a strong interest in reel-to-reels, and I like repairing them and doing modifications to them and generally messing with them. So some time ago I messed with a Sony reel-to-reel that had vacuum tubes amplifier stage, final amplifier stage. And after repairing this, I messed a little bit by attaching a guitar to the mic input of it, and I would hear the distortion it would produce. That was also that was done by the vacuum tubes during playing, and I liked it. So after that, I started thinking if it's possible to build some guitar fuzzes. It's called the guitar fuzz, that thing that I started thinking about how to build it and how to use it and all the stuff. And although I'm a very shitty guitar player, I play the bare minimum for electric guitars, but the sound that is produced during an amplification, when an amplifier stage is attached to the guitar, I thought it's a little bit interesting, so I thought I would mess with it. After all, a guitar fuzz is an amplifier stage, so I will learn something more about the electronics of it. To do this, generally, I built a device here, and this device is some sort of testing device for guitar fuzzes that I am about to start building, start thinking about how to build and all this. And look how this is. This is the input plug, and this here is the output plug. And this here is a volume control, and this is a voltage regulator for 9 volts. Generally, guitar fuzzes are powered by 9-volt batteries, and nearly all the schematics you're gonna find on internet, they are based on 9-volt batteries, but I wanted to use my 12-volt battery because I had this handy. 9-volt batteries, they dry out and then you have to find others, but these never dry out with such constructions anyway. So I put a voltage regulator for 9 volts so that I am able to attach the battery directly to this. Look how this can be used. For example, the input has these two cables which go directly to the input. When you try to mess with this, you have a breadboard. You put the breadboard here, and you have all the components that you might use. I have here transistors, and I have other components there to use and mess with them and make. So try stuff and see how it sounds. So this here is the input, red and black, and the black is also the ground for everything because all the blacks are connected here and here. They are all connected. You see this cable, it goes to this and to this and to this also. This is the voltage, the power supply, which is attached to the output of the voltage regulator. And this is the line out here that goes to this potentiometer. So it's ground and line out. And from the middle, I get the line out to this plug, so I can calibrate the volume output. This is 100K. It's a very common value for volume output. So I think I could attach it here permanently, but in any case, if I want something else, I can take this out and resolder the stuff here. What I have earned doing all this is that now I can try some schematics without any soldering, because all the soldering is already done. Generally, I don't know if somebody can solder or not, but if you cannot solder, I think you should try. I mean, a soldering gun is costs less than €5 or $5 or whatever, so you can just try it. It gives you enormous possibilities if you can solder. But if you cannot, you can just ask somebody to make something like that for you, and then you can try stuff on the breadboard and without any soldering. So this is what I wanted to present here, my device where I can try stuff. And here I have some components that I'm about to use: transistors, capacitors, resistors, a diode here, another diode here, and I will show you what we can do with all these. Okay, so when we are talking about guitar fuzzes, the most common one and the easiest one to build is this schematic over there. It's called the bazz fuzz, and it's really very easy to build, and it's the best one to start with. Okay, so I'm gonna sit down here next to it so that you can look at the same time what is going on there, and I will start building this on the breadboard. So this is input and this is output. First of all, let's find a transistor. The transistor for this is that 2N3904, which is that thing here. Okay, so with this, okay, this side is collector, this side is base, and this side is emitter. So we will put it here as a beginning, just like that, and I will start building around it. So the first thing we have here is that input capacitor. This capacitor I'm gonna use 4.7 microfarads. No. So I'm gonna use 1 microfarad. This is an 1 microfarad capacitor, and I will try this. And this 1 microfarad goes to the base of the transistor, and the negative side is this side. So I will put it like that. Okay, I don't know if you can see it, but okay. And the red of the input goes to this side here of the capacitor. So I will put it here. So the negative side will go to the negative side of the breadboard here, and this, which is the power supply, will go to the positive side of the breadboard, which is here. So that's what we have until now. Next, there is 100K resistor from positive power supply to the collector of the transistor. This is a 100K resistor, is it? I think so. Anyway, so I will put it from positive to the collector. Let's go, which is here. This side is collector, as we said. Next I think, okay. Next we have a diode. There it is. Yes, and it's that diode that goes to from the collector to the base, and the black side is to the base, and I will put it just like that. So it's there, and then there is the output capacitor, which is normally 100 nanos. I have a capacitor here which is 82 nanos. You cannot focus so close, and I will put it from the collector to the output. So from the collector to somewhere, wherever there, and then I will take this cable, which is for the line output, and I will put it near the end of this capacitor. Then I have to join the emitter of the transistor to ground. So I have here a jumper wire. Maybe I will use a normal jumper wire, which is something like this, and I will put it from the emitter of the transistor here to ground. Okay, there it is. That's already built, and now it's a good chance to test it. So here we can see a closer look. You see the resistor from positive to the collector, this diode from collector to base, this capacitor, if you can see, to the input to the negative side of the capacitor, which is here, and this capacitor here from the collector, here from the collector to the output, and then this cable goes to this potentiometer that goes to the output. Okay, so this is our final thing, and now let's test. We are ready for a first test of what we built. So I will not use a normal guitar amplifier. I will use just an active speaker, which is that here, so that we are sure that any distortion will come only from our our small thing here and not from any other in-between electronic stuff and everything. So what comes there is only what is coming out of there. I have here an adapter, you can see, so that I connect my active speaker to the output of this board, and let's see what we have. Power on the speaker. Okay. I have to power on the board. Okay, looks like it's making a noise. Let's see. As I said, I'm a city guitar player. And some Greek music maybe. Okay, so there is sound, that's good. Make some sort of artifacts, sometimes maybe because it's too loud for the speaker to handle. Yes, I think it's too much bass maybe. So, you get the point, how it's working. Or I will take out the power. Now, I have here a bunch of capacitors, and I will try something else. If you remember, the input capacitor here was 1 microfarad. I will try and use a 4.7 microfarads as input capacitor. Okay. So if you understand, the good thing about working on a breadboard is exactly that. We can do all kinds of connections here, change stuff and see if there is any difference. Okay. So again, and fuzzes, and now I will start doing many modifications. For example, here I have my transistor, which is the 3904. Here I have another transistor, which is the 550B. So this transistor collector and emitter is reversed with the one I had before. So if I put it like that, I will just reverse it and put it like that, and I will have the same results. Let's see if this transistor, the 550, works and how it works. Okay, in, power, works. Let's see what other transistors I have. 549 instead of 550. I should power off the whole thing here before, but I will not. I'm too lazy to do this. And let's see. Oh yeah. So generally, many transistors work. Okay, I will stop the video now, and I will try to do some other modifications. For example, if I take out this diode, which is the 4148, and put a red LED there. That means that this will reduce the voltage further to the base of the transistor, and I don't know what will be the result, but I want to try. I find it nice. So, this is for now our first board here using the bazz fuzz thing. So, what we can do here, we can use other resistors, we can use other capacitors, we can use other diodes, and we can use other transistors. And doing all this, we can, let's say, build our own sound somehow. I don't know, but I will keep on doing stuff and trying to see what I hear. That's all for now. Thank you. Well, I think I got the best results by using that 82 nano capacitor for the input, that which is 22 nano capacitor for the output, and this transistor here, where is it, which is the C550B. And let me show you how it sounds. This is the result. I can hear some kind of vibration. For example, listen to that. So I don't know which part of my setup produces this. It's the board here, it's the amplifier in this speaker, is the magnets here, or I don't know why this is produced, but there is a sort of vibration. Anyway, so this is the hear how it sounds. That's it with the bazz fuzz, and I got the best sound with smaller capacitors than on the schematic, on the original schematic on the internet. And I don't know why, I don't know which part of my setup makes it sound better like that. But this will be the finalization of the bazz fuzz for me, and I will move on to other stuff about fuzzes. Bye bye.